Hello everyone. As shared in previous videos about steam traps, from a theoretical perspective, you already have a basic understanding of how different steam traps work. Today we will move on to a practical video to observe how steam traps actually operate. This will help you clearly see how different types of steam traps discharge condensate differently. We operated a pellet-fired boiler manufactured by DIVI to supply live steam for testing the steam traps. This is a pellet-fired boiler with DIVI's latest design, featuring a very compact and space-saving structure. This boiler was designed for export markets and specifically for pellet fuel. The boiler capacity is 1 ton of steam per hour, with a design pressure of 12 bar and a maximum working pressure of 13 bar. 1.2 meters wide, 3 meters long, and 3 meters high. The structure is well arranged and equipped with full safety protection systems. Steam from the boiler is routed to a heat exchanger to transfer heat to water. After heat transfer, the steam condenses into water and is discharged through steam traps. Here we installed several different types of steam traps so you can observe them closely. This is a float-type steam trap, this is a thermodynamic disc trap, and this is an inverted bucket trap. During the steam system trial operation, we also conducted hands-on training for junior engineers and interns on boiler systems. The fuel combustion process inside the furnace has started. After about 10 minutes, the boiler begins producing steam at approximately 3 bar pressure. This shows the actual condensate discharge behavior of the 3 steam trap types. You can observe that the float-type steam trap discharges condensate continuously. The discharge process is almost uninterrupted. As long as condensate is present, the trap discharges it immediately. When condensate volume is high, the trap releases it rapidly with a large flow rate. When condensate volume is low, the trap continues discharging as long as condensate remains. In contrast, the thermodynamic disc trap discharges in intermittent cycles. After each discharge, the trap closes very quickly. The inverted bucket trap discharges condensate periodically and very consistently. You can clearly see the stable discharge cycle of the inverted bucket trap. This behavior matches the cyclic operating principle of this trap type. At this point, many of you may wonder why the steam trap appears to be discharging mostly steam with very little visible water. If the steam trap continues operating in a normal cycle, it indicates that the trap is responding properly to internal condensate. This condition is completely acceptable. It should not be immediately judged as live steam loss. The observed steam is essentially caused by pressure drop and flashing. The steam pressure at the steam trap inlet is 3 bar, while the condensate temperature is approximately 143.6 degrees Celsius. When discharged into atmospheric pressure, the condensate flashes into steam instantly. This is exactly why you see visible steam. When condensate is routed into the return pipeline and returned to the cold water tank, the flashing effect is significantly reduced. To fully condense this flash steam, a DIVI PCHR heat recovery unit is required. This also improves fuel efficiency. Disc traps discharge quickly, but handle low condensate loads, making them suitable for low-load applications. Inverted bucket traps discharge cyclically with stable performance suitable for steady and continuous loads. The float steam trap discharges continuously with a high capacity, making it well suited for use with control valves. Its discharge capacity is much higher than that of inverted bucket and thermodynamic steam traps. And we hope this video has been useful to you. Thank you for watching.